Okay, hello everybody. So today's video is a little different in various ways, not the least of which is you might spot it's not being recorded under Linux, it's being recorded on a Mac, but none of what I'm talking about today is specific to it being recorded on a Mac. It's something connected with a tool that we've recently been testing out and finding quite useful, but that does have some really quite concerning problems. Now that tool is the thing represented by this little icon down here at the bottom, which is Github Copilot. Now Github Copilot is effectively marketed as an AI-based pair programming system. And it can do some quite amazing things. If you think of it as being autocomplete on steroids sort of thing, it works really well. So for example, if I put in a comment saying function to solve a quadratic equation using the quadratic formula, parameters are a, b and c values as doubles, result is through a double star parameter, which must be at least 2 elements long. So I put in the comment, and then first of all here, it's doing something that's actually slightly annoying. It's saying returns a number of real roots found. Well, I may want that, but I may not. But I'll ignore that, and so I just hit enter to skip past it. And here we go. And yeah, I'm pretty sure that's done it correctly. It works out the discriminant. It's got the parameters here that I asked for, A, B and C as double, and a pointer to double for the results. It calculates the discriminant correctly. It works out that if the discriminant is less than 0, then this quadratic equation doesn't have real roots, and so it sets the result values to 0, which is fine. And if the discriminant is greater than 0, it puts the answers into the two results thing. So that works beautifully. So what is the downside to GitHub Copilot? And essentially the problem with it is you can't actually trust it. Everything it writes, if you look at it and can say to yourself, yes, that's right, it's brilliant. And if it's writing something that is difficult to work out how to do, but easy to verify is correct once you have the answer in front of you, it's amazing. And that's actually a fairly common sort of situation with, busy work. The problem with it is it will sometimes generate an answer that it really shouldn't do, either because it's just plain wrong or because it's outside the language standard. And I've found one example here where it is doing something that is a little bit of a vexed question about how it plays in with the standard, but the general consensus is it does something that the C++ language standard pretty explicitly states you mustn't do. I'm in C++ here. I have set it up to know that it's working with C++, but I've seen it do this with other things in other languages. And it's really simple to get it to generate this one. It's fairly reliable, which is one of the reasons why I'm making this video, because I can probably show it doing it live. So I'll put in a comment again. I'm going to say create a vec3 class representing a point in 3D, may as well spell Cartesian with a capital, Cartesian space, and I'm going to say that it's going to be accessed with square brackets operator. So I want it to create a class which stores 3 points, x, y, and z, and that I can access those points by doing square brackets 0, 1, or 2. And that's a really quite common thing to want to do. Now the first thing is this is something that GitHub Copilot sometimes does. It just wants to replicate the previous line. We're going to short circuit that, and I'm going to put in my class vec3. Knows that it should start with an open curly brace, that's right. Now we're just going to leave it a bit because this is actually quite tricky for it. So we just got to leave it while it spins. You can see down here. Okay, and it's now generated the code, and I will accept this code. Now, the first thing you'll see is it's actually generated a lot of good stuff. So, for example, it's implemented the plus equals operator, and it's done that correctly. And similarly, the minus equals, the times equals, divide equals. It's added things to get the length, things to normalize the vector. It's stopped here before it actually should have done, but that's not too difficult. If I just hit enter there, it'll generate more code. But you have to watch out for that, because that wouldn't have worked. But it's actually done something that it shouldn't do. So this sort of stuff, with just busy work in, it's actually not bad. There's a few things I'd say are a little strange, like this use of the old C maths square root f to do a floating point square root. I didn't tell it that I wanted double, so it's assumed I wanted float. But, you know, normally you'd use standard square root, which is overloaded for double and float, rather than the old-fashioned C-style float, but never mind. And but it's, you know, done nice things like put the literals in with a specifier to say that they are floating point literals, but it's done something really, really dangerous when it's implemented the square brackets operator up here, which is this line. So it chose to represent x, y, and z here as three separate values, which are members of the class vec3, x, y, and z. But I want to access that with the square brackets operator by an integer index. And it's gone, okay, what I'm going to do is I'm going to say, right, get the address of x and then subscript it like it was an array. Now, this is not correct. C++ does not actually give enough guarantees about how data is laid out inside a struct to allow you to do this. Because what this is doing is it's getting the pointer to x, and it's then going, okay, if I want x, I'm just going to go x of 0, which gets me x, that's fine. But I'm going to assume that y and then z are laid out immediately after x in memory. So if I access x like an array, then x of 1 is in fact y, and x of 2 is in fact z. And as I say, C++ does not give you enough information to let you know that that is true. And in fact, I'm pretty sure from reading the standard that it is actually genuinely undefined behavior, which is something you must never really cause to happen. Now, I don't know why GitHub Copilot loves producing this thing. Because it does. It will produce this time after time after time. You actually have to fairly explicitly tell it not to, or it will generate this idiom which is wrong time after time. And it is in fact really dangerous that it does, because it is incorrect and may break at any time, but in actual practical usage will probably work. Simply because it would be insane for the compiler to do anything but lay out x, y, and z in memory the way it is expecting. But the sheer fact that it will work does not mean that it is a good idea. Some compiler further down the line may break it. Particularly if you move to a different type of processor or something, this could easily break. So this is the problem with this. It's done a lot of good stuff. All of these things with operator plus equals, these constructors up here, testing for equality, that's assignment, not equality. All of these things I would have to have implemented manually, and it's implemented them for me. And it's done pretty much all of them absolutely correctly. But this square brackets thing here, it's done something really quite dangerous. And this is the problem. I say, so long as you are working with something where you can easily validate what it has produced, and you look over it and check it. This is why it's in some senses important that they sell it as a pair programming AI assistant. It does not do your work for you. You have to look at this like you were working with another programmer and going, have you done this wrong? Because as this shows, there is a real chance that it has. And yeah, you can fix it. I could write manually. I could give it more hints. I could put in this comment up here at the top that it should explicitly store not as 3 separate floats, x, y, and z, but as a 3-element array. And if I do that, it gets it correct, because of course a 3-element array really can be subscripted like it's doing here, and it works fine. It just adjusts all of these other functions to work with that 3-element array. So I think the thing to take away from this is we've been playing with these AI code generation tools. They are actually, so long as you keep an eye on them, really good. They can avoid some busy work, quite a lot of busy work, particularly in languages like C++ that are often really quite verbose because of the sheer amount of stuff like operators that you have to create. And they can save you time, they can save you effort, but they can generate dangerous nonsense that can break your code. So far, our verdict on them would be use them with care and treat the code they generate not like it's been generated by some godlike intelligence that's better than you, but like it's been generated by someone who's had a major blow on the head recently. The possibility that it'll produce real nonsense is quite high. So that's it, and we'll be back with another video soon.